or higher engineering or higher scientific mathematics, try to learn with us in online undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM, and hence keep concentrating, be serious, take every sessions and every class seriously, and hence you'll find that your life is going to be radically transformed. Everybody who is doing or who is a real engineer and a practical engineer and a lover of engineering mathematics, whether that you're a lover of higher scientific mathematics, I really appreciate about your presence. And this is Olenjolai Moko TAYAI single from the beautiful country called Tanzania. This is our national flag. I'm very happy to have you today. Whether you're a student, you're an undergraduate student, or you're a parent, or you're a guardian, or you're a sponsor, I have a good news for you. And this good news you have to deliver to the right destinations, to the right people who can get benefit on what I'm going to tell you in a few minutes. Welcome. I would like to take this opportunity to welcome you into one of our online institutions that called the Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Because I'm teaching mathematics, I would like you to use the terminology, the vocabulary, the common mathematical vocabulary that's called simultaneously. I would like to welcome you into our one of our YouTube channel that's called Online Undergrad Poly Institute of Tanzania in square bracket OLENJOLAIM. Well, possibly this is first time for you to meet me, and this is the first time to hear good news about Online Undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM. So you might be having so many questions. We really handle your questions. We cannot answer your questions within maybe 5 minutes, but we can answer some of the questions. And one of the questions that coming in your mind, what are we doing? Why do we need Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM? That's the very fantastic and very nice question in our mind and even in our mind. And that's the right questions that, and we are here to give you at least a piece of the response. What are we doing? What an assignment that we have in Online Undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM. And this assignment will be given by our manufacturer, who is God himself. We have a responsibility to teach, train, incubate, lead, mentor, and encourage some undergraduate students who are doing different programs in engineering and science, locally in Tanzania and even international in different continents, on how they can extract knowledge and wisdom, how they can extract and understand knowledge and wisdom from the formal and informal instructions in engineering perspective or science perspective, and combine the knowledge extracted and wisdom with the knowledge and the wisdom that we are going to teach them on how they can extract it from the Holy Bible in order to solve real life problems. So the main objective of Online Undergraduate Polytechnic Institute of Tanzania is not to teach students to pass exams. However, that in this lecture you will see that we are really helping you to pass exams because we want to reduce one of your stress. The main objective of Online Undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM is to train and teach undergraduate students on how they can take the classroom instruction to solve real life problems. I know it may seem like difficulty, completely impossible, but stay with me, you will see that it is possible because myself, I'm a product of what I'm telling you. I'm a product of a person who have learned different issues informally and formally and extract knowledge and wisdoms and then combine with the knowledge and wisdom that I use to extract it under the help of God himself, who is the author of the Holy Bible, and combining and solving the real life problems. You may be asking a question, what real life are you solving, Olenjolai? That's a good question. This is one of the real life problems that I'm solving, because right now I'm doing a program that is going to impact the entire nation for all the undergraduate students who are doing engineering and the science courses of the present and future generation. So I know that you are stressed, because I know that I'm trying to answer maybe the 10 questions in your mind. Maybe the first question in your mind is, you are stressed, you have been confused, you have given up, you hate higher engineering mathematics or higher scientific mathematics. So I want to tell you, don't reach into the conclusions. You have tried different methods on fixing your problems on how you can learn and master higher engineering and scientific mathematics, but possibly you found those methods are not working. I have nothing else to say about the alternatives you have used, but I have a good news for you, that please, before you reach into your final decisions to give up in higher engineering mathematics or higher engineering or higher scientific mathematics, try to learn with us in online undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM, and hence keep consecrating, be serious, take every sessions and every class seriously, and hence you'll find that your life is going to be radically transformed. So I would like just to take this opportunity to welcome you. We have more than 3 departments in this online institution. One of the departments is called Departments of 40 High Engineering and Scientific Mathematics, where we are teaching our students more than almost 12 modules or courses, and one of the modules or the course is called the calculus. And then today we are in chapter 5, very interesting chapter. This is called the Fourier series. And then we are lecture 6 of problem solving of the Fourier series of periodic function of period of 2 pi. So then this content is for NTA level 7s, because in Tanzania, remember that this is kind of a quick review. I would like just to remind you, in Tanzania, because we are focusing into the syllabus of Tanzania. So in Tanzania, we have 2 different systems. We have, in undergraduate level, or in higher educations, we have TCU, and also we have NAT. So TCU is technical, we call it Tanzania Commissions for Universities, and this is National Council for Technical Education. So in these modules, or in this course, we are going to use the curriculums of 40 of NAT. So the curriculums we are going to teach you are going to use the curriculums, the sequence, but remember, curriculums is universal. So Fourier series is the common topic I have ever found in different institutions, in any institutions or college or university of engineering or science in Tanzania, and even in Africa and worldwide, they used to cover this material. So stay connected. Possibly that the names is a little bit different. That is called Engineering Mathematics 1. Don't worry and don't confuse about the names, the issue, the content. So in Tanzania, especially at Dar es Salaam Institute of Technology, where I use the year curriculum specifically as just a reference. We have NTA level. So NTA level, we have NTA level 4, NTA level 5, NTA level 6, 7, 8, and 9. So for undergraduate, we have 2 levels, NTA level 7 and NTA level 8. So high engineering mathematics and higher scientific mathematics is being covered in NTA level 7 for undergraduate students. So remember that here you are going to receive the contents which have been prepared for the excellent and even competence-based engineers in undergraduate level. So you have to join me right now into today's. Before we start our session, remember that I'm not only a teacher of higher engineering and scientific mathematics, but I'm also an electronic and telecommunication engineer. So that's why I have a very special overcoat to indicate that I'm ready to deliver good information about engineering mathematics and scientific mathematics for the undergraduate engineer. So take your materials. We have also online library that will be sharing to you in the next session about what you are providing. So take your material right now, and then let us kick the stuff, and then let us lead. So just to do the quick review, we have in Fourier series what we have covered. First of all, we have covered the general formula of Fourier series that we need. Okay, Fourier series is given as So if you do remember that you say it's a function ffx or ff theta, then the first Fourier coefficient a0, then we have sigma notation or summation from n is equal to 1 to infinity. And then here we have an, we have cos of nx, then plus what? Plus bn, sine of 40. So then we say sine of 40 of nx. So this is the general formula. But again, we have initial Fourier coefficient, which is 1 over 2 pi. So integral from negative pi to pi, then we say ffx dx. Then we have another Fourier coefficient an, this is 1 over pi. Then we have integral from negative pi to pi, then we have the product between the function and the constant function and a variable function called cosine of nx dx. Then we have the last Fourier coefficient bn, this is 1 over pi, then integral from negative pi to pi, then we have ffx, then we have sine of nx dx. So today we are doing correction, okay? So today we have solved almost the 6th question, correction of 40 of homework 6. So in homework 6, I left a question which is kind of conceptual question. And this homework 6 we numbered, if you do remember that in our session, we numbered as example 7. So this is example 7. Let us do correction. I believe you did it. I didn't see it in the comment section. Possible that maybe some students they can send. You are not late. You can send your solution to the comment sections or by using other platform that I'm going to share with you. So to handle this question, let me write it. Okay, let me write in this column, and then we are going to solve it because the one of the long questions. So we are going to solve these questions and end up the first topic of Fourier series. So determine the Fourier. So the question was stating that determine the Fourier series series for fold. For the fold. So the word fold is very important for the full wave. Okay, full wave rectified, full wave rectified sine wave. The full wave rectified sine wave. So in this sine wave, we've been given as I. I stand for the symbol of the current. So we are dealing with this one when we are learning the concept in physics or in electrical engineering or in electronics engineering. That's called AC theory. So this is the symbol for the current. The lower height is symbol for the current. 5 sine of theta over 2. This is the angle made by the sinusoidal signal. Okay, shown. So shown in figure below. So in figure 6, 21 below. This is 22 because we had also the other one, 22. So we'll be given, so let me sketch. This is y-axis. And this is x-axis. So remember that this is y-axis, but according to the equation, this is I-axis. And it's theta axis. So we've been given a representation like this one, that this is a full wave, and then we have another full wave, then we have another full wave. So here we have 2 pi, here we have 4 pi, and here we have 6 pi. All right? 6 pi, or either 2 or whatever. This is the orders. And then here we have again another full wave. And we have negative 2 pi. Then we have another full wave. Okay, another full wave. Then this we call tot. So they have all of these full wave have the same dimension. It's just a matter of possible that I'm not drawing, but I'm sketching, so I'm not using the proper measurement. So this is figure. So we are given this figure 6.2. Okay? So that's the question. And we have the corrections of that homework 6. That's the question that I left for you. So ladies and gentlemen, I'll be leaving this question here. So let us solve. We are going to follow more than 10 steps on solving this problem. Okay? If you did your homework, then now it's the time for correction. Take this advantage at the moment for you to do correction. Okay? So the first step, why are we given this figure? That's the first question. We given the function according to find the Fourier coefficient, we need to know the function and the limits or the curve itself or the cycle. So it means that the first step we have determined the lower interval. So first step you have to use figure 6.2 to what? Determine what? Lower and the upper limit. Lower and upper limit of the function FCT's function R. So when you check this one, the half cycle is from 0 to pi. This is the half cycle. But the full cycle, the full wave, is from 0 to 2 pi, from 2 pi to 4 pi, from 4 pi to 6 pi. So the interval here it is 2 pi, 2 pi, 2 pi. 2 pi, right? And even here it is negative 2 pi. So when you are dealing with only one, consider one full wave rectifier. So we have to consider one full wave. So one full wave. Consider one full wave. Okay? So consider one full wave. So we say that the interval. So the intervals are. So when you consider one full wave, so the intervals are from what? 0 to 2 pi. So it means that the lower limit from there, the lower limit is equal to 0. The upper limit of the interval. So the upper limit of the interval, this is equal to 2 pi. So we have to make sure that we use the different, we have to recall these 4 formulas because the questions asked to find the Fourier series. But we have to change the limits because in these 3 formulas of finding the Fourier coefficient, first Fourier coefficient, second Fourier coefficient, and third, enjoy the beauty of higher engineering mathematics. Enjoy the beauty of higher scientific mathematics for undergraduate. So we have to recall these formulas, but we have to change the limits from negative pi to pi. Okay? So you say that if that the case, means that useful limits, okay, of what? Of intervals of Fourier coefficients are 0 to 2 pi, and not negative pi to pi. And this is correct also, because this is 360 degrees, and this also is 360 degrees. So we may use this one depending on the intervals or the limits which have been given in the question. Okay, so if that's the case now, ladies and gentlemen, it's a moment now we have to go for the first step. So to find all the Fourier coefficients, we use the intervals from 0 to 2 pi. All right? So we go for the second step. So the second step, we say that we have to recall the formula of the first Fourier coefficient, the formula of A0. So the formula of A0, this is equal to, so 1 over 2 pi, integral from negative pi to pi, then f of x dx. But according to the given function, the independent variable is not x today, it is theta. So you have to change. Okay, so this is A0 is equal to 1 over 2 pi, integral from the intervals now from 0 to 2 pi, but we have to change our function from x into theta. So f of theta d theta. So then we have to find A0. Okay, so you have 1 over 2 pi, integral from 0 to 2 pi, and that's what is f of theta. It is I d theta. So what the value of I is, this is integral from 0 to 2 pi, I it is 5 sine of theta over 2 d theta. So then we are finding a naught, we have to integrate that function, the finite intervals. So we take 5 out, then we have 5 over 2 pi, then we integrate from 0 to 2 pi, then our function is sine of theta over 2 d theta, right? So the next step, we have to integrate. So if you integrate positive sine, you get negative cosine. So the answer is 5 over 2 pi. When we integrate, we get what? We get negative cosine of what? Of the angle, which is half angle, theta over 2. But we have against another constant, which is a half, according to the rules of integration that I told you, from 0 to 2 pi. So then a half, this is equivalent to what? A naught, this is equivalent to 5 times 2, because 1 over half is equal to 2. Then over 2 pi. And we have the integral of negative cosine of theta over 2. This is from 0 to 2 pi. Right. So now we are enjoying the view. So we don't, okay, I know that you have copied the function, we have copied the question. So now it's the time for you to enjoy the beauty of higher engineering mathematics and the beauty of Fourier series. My friend, my students, I want to tell you one of the very interesting topics in high engineering mathematics that I do love myself, and even I convince you to love it, is Fourier series. So stay tuned, nothing is difficult there, it's just to use the ordinary concepts of integrals that you have to remind you. So stay tuned, don't hate mathematics, please. Keep your love with high engineering mathematics and master it. Okay, so then if this is the case, now we have to substitute our lower and upper limits. We have to simplify. 2 over 2 is equal to 2. So here we have 5 over pi. And then on this side, we have what? We have negative cosine of 2 pi. In theta, just replace 2 pi over 2. Then minus negative cos of 40. The lower interval is 0. Okay? So ladies and gentlemen, a naught is equal to 5 over pi. And then 2 over 2, so we have negative cos of pi. Pi is equal to 180 degrees. So negative cosine of 180 degrees, this is equal to positive 1. And then negative times negative is equal to positive. Cos of 0 is 1. So ladies and gentlemen, here we get 2. 2 times 5 is 10 over pi. So the value of, very important, of the first Fourier coefficient is 10 over pi. That's the end of the second step. Did you get it? I believe that this is, according to my research, when I was teaching this topic of Fourier series for the 6 years physically, most students, they used to get this first Fourier coefficient, but the challenge is the second Fourier coefficient and third. So let us go to the challenging point right now. That maybe you've given up and you say that I can't manage to solve this. No, you can. So the third step, we say that call the formula of what? Of an and find it. Okay. So the form of an, this is equal to 1 over pi, the general formula, from negative pi to pi. And then we say that this is f of x cosine of x and, or any x dx. This is the general formula. But remember that our independent variable today is not x, it is what? Theta. So you have to change that. So remember that x today is equal to theta. Again, our limits today are not from negative pi, to pi, but our limits are from 0 to what? To 2 pi. So you have to make sure that you change the limits. So now an is equal to 1 over pi, integral from 0 to 2 pi. And then our function is f of theta, then we have cosine of n theta, then d theta. That's the first equation. So let us substitute the value of fi theta. So with this one, we find that an is equal to, ladies and gentlemen, 1 over pi, integral from 0 to 2 pi, and f theta is I, then cosine of n theta dot d theta. So ladies and gentlemen, this is 1 over pi is equal to 1 over pi, integral from 0 to 2 pi, and then I it is 5, 5 sine of theta over 2, then this is cosine of n theta, then what is theta. So ladies and gentlemen, if we start on simplifying, 5 is common, we take out of the integral 5 over pi. This is integral from 0 to 2 pi, and then we have what we have sine of theta over 2, then we have what we have cosine of n theta d theta. Right. So suppose that this is the first equation, because we are going to have a number of equations. I believe that you enjoy the beauty of higher engineering mathematics and higher scientific mathematics. Well, so there we are. So when we examine, in order for us to integrate this integral, or to integrate the integrand, which is sine theta over 2, cosine of n theta d theta, right? This is integrand. We call it an integrand in calculus. So an integrand is the function, it's a product of the two trigonometrical functions, cosine of the half angle, and sine of the half angle and cosine of n theta, which means that of multiple angle. Then this is just a derivative, okay? So in order for us to integrate this function, if you examine this function, we find that this is the products of the two trigonometrical functions. We don't have any alternative on integrating rather than to recall the concepts of the factor formula in trigonometry. So ladies and gentlemen, at the first stage, I know many, according to my research when I was teaching physically, many students, they used to get stuck when they reach here because they forgot and they don't think that we need some concepts of trigonometry in integration. So they used to say that, Fourier is kind of the interesting topic, but the challenge is on how to integrate different functions. But if you refer my program or my videos in, especially that in one of our another online school that called Tanzania, just for engineers, just we call it online diploma Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. I used to teach also my students about how you can integrate functions by using factor formula. Okay, so the first step we say that we have to recall factor formula, and hence we have four formulas of factor formula. So factor formula of what? Of cosine or sine, because the products between the sine and cosine, you have to think of the sine. But when you check, we compare this angle and this angle, which is large. This is the largest angle compared to this one. Because even if we place here n is equal to 1, we get theta. Theta is greater than theta over 2. So it means that this is the smallest angle and this is the largest angle. So we have to recall the factor formula of sine. But we have to subtract this sine function. So we say sine p minus sine q. This is equal to what? So this is equal to cos of what? Of p plus q over 2 multiplied by what? By sine of p minus q over 2 and then over 2. That's the factor formula of sine from trigonometry. No, this is twice. Excuse me, this is twice. So twice of this. So let us divide by 2 both sides. So on the left hand side we have what? Sine of p minus what? Sine of q of what? Over 2. So this is equal to what? This is equal to sine of what? Of p minus q over 2. Then we have cosine of p plus q over 2. Well, so suppose that this is equation 2. Question 2, right? Question 2. So we go for the fifth step because you have to know the values of p and q. I know many students they used to claim the value of p and q, but we have to find according to the given function. So the fifth step we have to say that we have to compare right hand side of what? Of equation 1 and the right hand side of equation 2. Or the right hand side of equation 1, usually. So how do we compare? So we know we just compare the integral. So it's a sine of theta over 2. Then we have cosine of n theta. This is equal to what? This is equal to sine of p minus q over 2. Then times what? Cos of p plus q over 2. So if we compare sin theta and sin theta cancel, So we get the first equation, the third equation, theta over 2, this is equal to P minus Q over 2. So if you simplify, you find that theta is equal to P minus Q, and this is the third equation. Okay? When we compare the cosine function now, because we've compared the sine function, we compare the cosine function. On the left-hand side, we have what? We have cosine of what? Of n theta. This is equal to cosine of P plus Q over 2. So, ladies and gentlemen, this and this cancel. So this is 2n theta, P plus Q, and this makes equation 4. So what is our responsibility as mathematicians? To find the value of P and Q first, and hence we restore back into our integrals and simplify our integrals and express in a very simplified trigonometrical function, which we can integrate easily by using just the normal rules of integrations, right? That's what we are doing. That's why we have to think different. It's difficult for you, or it's difficulty for undergraduate students to integrate this function without using the factor formula of sine. That's according to the facts from mathematics. So we go for the sixth step. We are still looking, so tell your neighbor, we are still looking at A of m, the Fourier coefficients of A of m. So let us solve simultaneous. So let us solve what? Let us solve the equation. Question 4 and D, question 3. How we solve it? So we have P plus Q is equal to 2 and theta. Then we have P minus Q is equal to theta. So to solve it, we can add. So if we add these two equations, we get to P, Q plus negative Q is equal to 0. And then this is 2 and theta plus theta. So divided by 2, divided by 2. So simply, the value of P is equal to what? Is equal to 2 and theta over 2 plus theta over 2. So simply, the value of P, ladies and gentlemen, this is equal to n theta plus theta over 2. Okay. Then we have to look for the value of Q. So the value of Q, simply, we have to take equation 4, P, equation 3, P minus Q is equal to theta. So we have P minus theta. So P minus theta, this is equal to Q. So Q is equal to what the value of P? P is n theta plus theta over 2 minus what? Minus theta. So, ladies and gentlemen, Q is equal to what? N theta minus what? So minus theta over 2, because this is a half minus 1. This is negative a half. So you have the value of what? Of P and the value of what? Of Q. So suppose that this is equation 5 and this is equation what? So this is equation 6. So you have the value of P and what? Q. So when you have the value of P and Q, you have to substitute them in equation 2 on the left-hand side of what? Of equation 2. So that's the next step. You have to substitute the value of P and theta on the left-hand side of equation 2. So we go, this is the seventh step, still using the factor formula. And the good thing is, we are going to do some business when we're looking for A, B, Bn. So seventh step, we say that in the seventh step, we have to say that substitute equation 6 and equation 5 into equation 2. So into equation 2. Okay? So to substitute into left-hand side of equation 2. So to substitute it right now, we are going to have sine of what? P. What the value of P? P is n theta plus theta over 2. Then we have what? Minus sine of what? This is a simplified trigonometrical function. Sine of n theta minus what? Minus theta over 2. Right? And then we have what? Over what? Over 2. So if you check this function, this is equal to the integrand. Where is our integrand? So our integrand is what? Sine of theta over 2 multiplied by the cosine of n theta. So this is what? This This is equation 7. So you go for the 8th step. So the 8th step, we say that substitute, I believe you're showing the beauty of high engineering mathematics, the beauty of Fourier series. Substitute equation 7 into equation 1. So we were looking the value of an, and we had what? So we had the integral of what? So I forgot the outside. Also we had 5 over, is it 5? Yeah, 5 over pi. 5 over pi, integral from 0 to 2 pi. Now our new function is, we have to integrate what? We have to integrate a new geometrical function, which is more simplified or more simple compared to the first one. Sine of n theta, then plus theta over 2, and we have to minus, we thought sine of what? Sine of n theta minus theta over 2 divided by what? By 2. So this is the replacement of the first integrand, then the theta. So 2 is common number, so then we can define like this one, that 2, so 5 over 2 pi, then we have integral from 0 to 2 pi. Now we have two sine function. The first one is integrations of sine of n theta plus theta over 2 d theta, and then we have to plus is 0 to 2 pi, then not plus, minus, excuse me, minus sine of what? Of n theta minus what? Minus theta over 2 d theta. And then we close the curly bracket. So now we have to remember on how we can integrate what? We can integrate a sine function, okay? How can we integrate a sine function? That's the question. We can integrate a sine function by using a very interesting way, because if you integrate positive sine, you get negative cos. And if you integrate negative sine, you get positive what? Positive cosine. But before we integrate, theta is common. Let us take theta out. So if you take theta out, ladies and gentlemen, an is equal to 5 over 2 pi. So we take that 0 to 2 pi, and then we say what? Sine of what? Sine of n plus a half theta d theta, then we minus with integral from 0 to 2 pi, then we have sine of what? Because this is common, n minus a half, right? Then theta d theta, then close the curly bracket. So this is the constant now of the angle, and this is the constant. So we can even also have another bracket like this, just to distinguish it from the differential variable, which is theta. So this is the constant. So if we integrate this according to the rule of integration, right? So the an, if we integrate, we have 5 over 2 pi outside. Then we are going to have, again, this result after the integration. Okay? If we integrate positive sign, we get negative cos of what? Of n plus a half. If I'm not mistaken, n plus a half theta, but also we have a constant here which becomes as denominator, which is n plus 1 over 2. Remember, is when we're integrating sine of n plus 1/2 theta d theta, it's like we're integrating sine of 5 theta. If you're integrating sine of 5 theta d theta, then the response will be negative cosine of 5 theta over 5. So the coefficient of the angle become as a denominator of the origin of the response. Then we have to define our limit from 0 to 2 pi. Then, if you integrate sign again, so you have what is negative. Negative is positive. So it means you can change this sign here and put positive, and here having negative sign. So simply we have put positive, and then right now, if you integrate negative cosine, we have this is sine of n minus a half. Okay, this is cosine of n minus a half. Then we say that theta, and from what? From n n minus tens over n minus a half from 0 to 2 theta, then we close the curly bracket. Wonderfully done. The question was very interesting. It was really challenging to test whether you understand or you claim high engineering mathematics, whether you love Fourier series or you hate it. Okay, so wonderful. So when you reach there now, we have a very interesting, we can examine. When we reach there, the techniques which I want to tell you, you can try to plug the value of n. When n, remember the first value of n is 1. So when n is equal to 1, representing what? Odd number, the first odd number. And the second integer, which is even number, is 2. So you can solve them. In case you find 0, then you cancel, then n is equal to 0. So you can check. So you substitute n is equal to 1, 1 plus a half is equal to 3 over 2. So 3 over 2, okay, so 3 over 2. I think that this checking, we have to do it after substituting the limit, because we didn't plug the limit. So an, ladies and gentlemen, we have a long expression. It is 5 over 2 pi. And then we have the curly bracket. So ladies and gentlemen, we have what? We have a negative what? So here we have negative cosine of what? Of n plus a half and theta and 2 pi, right? And then this is what? Of what? Over n plus what is a half? N plus a half. But this one is minus, so it will be plus what? Plus cos of 40. Cos of, because 0 times n plus a half is 0. So plus cos of 40, cos of 0. Okay? So then we say plus. Same story, same situation. Cosine of what? Of n minus a half, 2 theta, 2 pi, excuse me, then minus what? So for here it will be minus cosine of 0, then divided by denominator, which is n over a half. Okay? N over a half. So then, so if that's the case, you say that, okay, in this step right now, before even you go, this is cos of 0. Okay, cos of 0. And here we have cos of 0. Okay, so you can simplify further and then check. An is 5 over 2 pi. Okay, so 5 over 2 pi. Then there we have what? Cosine of what? Of n plus a half, 2 pi, plus what? Cos of 0, which is 1. Then this is n plus what? N plus a half. So this is n plus a half. N plus a half. Okay? And then we say that this we have to plus is what? Positive cosine of what? Of n minus a half, 2 pi, plus what? 1 of what? Over n plus what? Plus a half. No, minus a half. Thank you very much. Then close the curly bracket. So from there, we can now check everything. Writings by using small letters or small just to make it help you to check. Okay. So an we say that, okay, so you can check now. You can check. Okay, so you can check. So we go for the what? We go for the 10th step, 9th step. So the 9th step, check if an is equal to 0. How? So it means that when n is equal to 1, you have to check. When n is equal to 1, 1 plus a half, just checking. 1 plus a half, it is 1.5 or 3 over 2. 3 over 2 times 2 pi is equal to 3 pi. Negative cosine of pi is equal to what? Positive 1. Positive 1 plus 1 is 2 over what? 3 over 2. So this will never, for the odd terms, it won't be 0. For the even, for the odd, let us come here. So 1 minus a half is a half. So a half times 42 pi is pi. is pi. 1 minus a half, it is a half. Okay? It's a half. A half times 2 pi, it's what? A half times 2 pi. A half times 2 pi, it is what? So a half times 2 pi, it is pi. So because of that, that's what I wanted just to say. So we can also do some maneuvers because we want to avoid this term to be 0. The way that we have to do some maneuvers, we say like this one. So listen carefully. So listen carefully. So we know sine its OD function, I told you. So it means that we can change this function this way. We can take negative out. So when we take negative out, this n become negative n. Why this one become positive? But negative and negative become positive. Okay, so it will be a half minus n. And there is a purpose to do that. And the purpose is we want to avoid these terms to be 0. Or according to that condition. Because we have cosine of what? This will be minus 1. Oh, wonderful. This will be minus 1. Why minus 1? Yes, because cosine of that one. So yeah. So it means that it does not need even to change. Just restore the previous values. This is negative. Okay, this is positive. This is positive. And this is what? Negative as usual. So everything is okay. So cos of negative pi is negative 1. Then if you have also to avoid this, there's a specific property that you have to try our level best to avoid. Yeah, you have to avoid this property of having 0 because you are going to have negative 2 there, or 3 over. So there it will be 3.5. Will it be 0? Okay, to avoid just the confusion, we can say that we can do the maneuvers I told you. We have to take negative out here. So this one becoming positive, and then this becoming negative, and this will be positive. So sine is only function. So if that the case, we have to say that even this one, this is positive, negative, positive, negative. Positive, negative, right? So if that the case, we say that here we have positive and here we have negative cosine also because everything is positive. So if you have negative cosine, you have to make sure that we do changes in the second. So this is positive a half minus n, and this is plus this one, and here it is what? It is negative. It is negative. So simply here it is still negative, but here it is positive. Then over this is positive, negative, and then this is positive, negative. So simply the an, so before even we check, okay, I forgot to do those that transition in advance. So simply an is 5 over 2 pi, okay, 5 over 2 pi, and then here we have what? Negative cos of n plus a half 2 pi over what? Over n plus a half. So then this one, we say that plus 1. Alright? Plus 1. Then we say that here we say we have plus, we have cosine of what? Of a half minus n, then twice pi, then we say plus what? 1 of what? Over n over negative n plus a half. So from there we go for the 9th step. Okay, 9th step, we have to check. So the question like this one can worth 10 marks in exam, in a final exam. Check if an is equal to 0. No, an is equal to 0. How? First of all, substitute n is equal to 1 to test it for odd, and n is equal to 2 to test it for odd, for even. So when n is equal to 1, 1 plus a half is 1.5 times 2 pi, because you have to times 2 pi before we find the cosine. So the answer is what? The answer will be 3 pi. So negative cosine of 3 pi is equal to 1. 1 plus 1 is 2. And here it will be 3 over 2. So this term will never be equal to 0 when we have odd terms. We come onto this test. A half minus 1 is negative a half. So negative a half times 2 pi, that is equal to what? Is equal to negative pi. Negative cosine of negative pi is equal to positive 1. 1 plus 1 is 2. So then 1 minus 1 is what? It's negative a half. So this term will never be equal to 0 for odd terms. For even terms, let us substitute. Whenever we have n, let us place 2. 2 plus a half is 5 over 2 times 2 pi is equal to 5 pi. Negative cosine of 5 pi is 1 plus 1 is 2. So here it is 2 plus, and it will be 5 over 2. Similarly, here when n is equal to 2, a half minus 2 is equal to negative 3 over 2. Times 2 pi, we get negative 3 pi. Negative cosine of negative 3 pi is equal to positive 1. Plus 1 is 2. And a half minus what? Minus 2 is equal to negative 3 over what? Negative 3 over 2. So even also an will never be equal to 0. So it means that an will never be equal to 0 for any circumstance. But we can also simplify by using these values. We can simplify because we have to find the common terms. So we say whenever we substitute whether n is equal to 1, n is equal to 2, try for n is equal to 3, n is equal to 4. We'll find this. That here we have 5 over 2 pi. And then whenever we substitute here, we'll get positive 1. So we'll get 1 plus 1, always we get 2 in the numerator of this function for any value of n. And in the denominator, we still have what? We still have n plus what? It will never change. So 2 will be common for any value of what? Of n. So the value of this numerator function is 2 because all of this term, when n is equal to 1, this term gives us, this function gives us 1, 1, 1, 1, 1. When n is equal to 1, this value its value is 1. When n is equal to 2, its value is 1. When n is equal to 3, its value is 1. When n is equal to 4, its value is 1. So 1 plus 1 is 2. That's why we have 2 over n plus a half. Similarly, when n is equal to 1, here we get 1. When n is equal to 2, we get 1. When n is equal to 3, we get 1. When n is equal to 4, we get 1. When n is equal to any real number or any real integer, the value is 1. 1 plus 1 is what? 2. So even here, we are going to have it is 2 over what? Over a half minus n. So this, ladies and gentlemen, this is our general formula of what? Of an. Okay, of an. So that's what we have been looking for. Okay, so the next step right now, we finished. We cannot write the Fourier series until we find the value of bn. Okay. Then we go to the 10th step. The 10th step is this one. We have to find bn. The general form of bn is 1 over pi. Integral from negative pi to pi. Then you have f of x. Then you have sine of nx dx. So we have to transform this. Bn still equal to 1 over pi. Then we have integral. Our intervals are from 0 to 2 pi. Then f of theta, it is what? It is I, which is 5 sine of theta over 2. Then we have times what? Sine of n theta d theta. So this will be equation what? I think I ended equation 6, so this will be equation 7 if I'm not mistaken. If I ended equation 7, just name equation 8. Again, here we have a product of the two trigonometrical functions. These are the these are the same, it's the same function side, but of the different angles. So when we're integrating the products of the two trigonometrical sine function of the different angles, then that's difficult to integrate unless we have to refer or to recall the concept we taught you that's called factor formula of cosine in trigonometrical or in a topic of trigonometric functions. Okay? So to integrate it, we go for the 11th step. So 11th step, we say that we have to recall for what? Recall the factor formula of what? Factor formula of cosine. Okay, cosine. That factor formula states that cosine of angle P minus cosine of angle Q, this is equal to what? This always, ladies and gentlemen, is equal to -2. Then we have sine. Why are we recording this? Because of the products of the sine function. Sine of P plus Q over 2. Then we have times sine of P minus Q over 2. So to simplify, we have to divide by -2, and this side we have to divide by -2. So ladies and gentlemen, we have cosine of P minus cosine of Q divided by what? By -2. I believe that you understand. This is equal to what? Sine of P plus Q over 2. Then sine of what? Of P minus Q over 2. Over 2. Okay? So this will make equation what? Equation 8. So if we compare now equation 8 and equation 7, so you'll find that we have the same, we are going to formulate the same equation. Okay? So it means that if you compare, it means if you compare, we can find, if you compare what? Equation 7 and what? And equation 8 as we did it, then we get what? So we get P minus Q is equal to what? Is equal to theta, and then we get P plus Q is equal to 2n theta. Right? So simply, the aim, we solved those two equations and we found their values. So right now we have just to refer and say that P is equal to what? P, the value of P, the value of P, it is what? P is equal to n theta plus a half plus theta over 2, if I'm not mistaken. Yeah. And then Q, it is n theta minus theta over 2. Right? Okay. So if that's the case, we have to take the values and substitute them into this function. So substitute, so we say this is 12 step. Substitute values of 40, values of P and Q in equation what? In equation 8. This is question 8, ladies and gentlemen. This is question 8. Okay. So if you substitute, we're gonna find that we have cosine of n theta plus theta over 2 minus cosine of n theta minus theta over 2. Right? And this one over -2 will be equal to what we have compared, what we have here. So there we have sine of theta over 2 and times sine of n theta. So this will formulate equation what? 9. So then we say that we go for the 13th step. 13th step, we have to substitute equation 9 into equation 7. So to substitute it, we have what? B of n is equal to what? 5 over pi. Then we have what? Of interval from 0 to 2 pi. And then what? 2 pi. So we have cosine of n plus a half theta d theta. Then we have to minus this interval from 0 to 2 pi. Then we have what? Cosine of n minus a half theta d theta, then calculate. Okay. So ladies and gentlemen, there I will show you the trick that how you can get the answer of that of this function easily without too much of the hassle. Okay? So if we integrate according to the intervals that we have, we get pi for 5 over pi over 2 pi over so this is negative what? So we have negative 2 somewhere. Negative 2. Okay, so negative 5 over 2 pi. Negative 5 over 2 pi. And then after we integrate, if we integrate cosine, we get what in sine, sine of n plus a half theta over a constant n a half. So now I believe that you are getting the picture. 0 to 2 pi. Then we have to subtract. We show it. When you integrate cosine, you get sine of n minus a half theta of what? Over n minus a half. But now our limit is from 0 to 2 pi. Then you close the curly bracket there. Okay? So then substitute the limit. So Bn is equal to, because from after you substitute the limits, you can see. So this is equal to what? So this is equal to sine of what? N plus a half, but the angle is 2 pi. Of what? Over n plus a half. But there we have to minus with sine of 40, sine of 0. Not theta, 0. Okay? 0. So this is the first part. Then we have to minus this what? Sine of n minus a half, 2 pi. Then minus what? Sine of 0 of what? Over n minus a half. So from here we can check whether Bn is 0. How? When n is equal to 1, we get 1 plus a half, which is equal to 3 over 2. When you take 3 over 2 times 2 pi, we get 3 pi. Sine of 3 pi is equal to the sine of 270 degrees. So it is what? It is 0. And this is 0, this is 0. These two terms, they don't have any contribution. When n is equal to 1, so this would be what? The 13th step. The 13th step, you say that check before you take too much hassle if Bn is equal to 0. So n is equal to 1, this will test the odd terms. When n is equal to 2, this will test even terms. So when n is equal to 1, 1 minus a half is equal to a half. A half times 2 pi is equal to pi. Sine of pi is equal to sine of 180 degrees, which is equal to sine of 0. So when n is equal to 1 for all the odd terms, Bn is equal to 0. Let us go for the even terms, right? Do you understand the concept I'm building in your mind? This is the new concept, but it will be built up as long as we go, because sometimes you can do too much of work while the terms is 0, while the Fourier coefficient is 0. So you have to examine, you have to check, and you have to inspect. Okay, so when n is equal to 2, 2 plus a half is equal to 5 over 2. 5 over 2 times 2 pi is equal to 5 pi. So sine of 5 pi is equal to sine of 5 times 180, which is equal to 0. Then again, when n is equal to 2, 2 minus a half is equal to 3 over 2. 3 over 2 times 2 pi is equal to 3 pi. 3 pi is equal to 270 degrees, sine of 270 degrees to 0. So if that's the case, even if, for the even terms, Bn is equal to 0, right? So simply it makes, we just say that this term goes to 0, and this term goes to 0, and if that's the case, Bn is equal to 0. And you have already determined the Fourier coefficient. Wonderful. Wonderful. You have determined the second Fourier coefficient easily without too much of the hassle. So I will teach you this because I'm going to teach you more than 20 examples of Fourier series in this module or modules of calculus. So you have to stay tuned. This is just example 7. So I'll build up these concepts of inspecting the expressions or the integral functions or after integrating, and then you see if the Fourier coefficient goes to 0. Okay. So if that's the case, now we go, ladies and gentlemen, into the 14th step. And the 14th step, we have to find what? So we have only one term, two terms which are not equal to 0. And I'll teach you about even and odd function. If you check that function, it is odd function. So I will teach you in the next in the next chapters. I will teach you about this, because if you examine the graph, you'll find that that was the odd function. So if the odd function a naught is not equal to 0 in many cases, but however in some cases it can be equal to 0, but an is not equal to 0, but bn is equal to 0. Stay tuned. I have a good news for you. Okay, so find 40. So find a1, a2, a3 from what? The an, in order to write the Fourier series. From the an, and this an, it is 5 over 2 pi. If you remember, 5 over 2 pi, here you have 2, then you have n plus a half, then plus what? 2, here you have n minus a half. So this is our, yes, no, this is a half minus n. It's a half minus n. So we are looking for a is equal to 1. We are looking the value of a when n is equal to 1. So 5 over 2 pi, then this is equal to what? 2, then you have what? So you have 2, you have 1 plus a half, and this one we make it 2, then you have what? A half minus 1. So a1 is equal to what? 5 over 2 pi. So this is 2 over 3 over 2, then plus what? 2 over half. So this is equal to 5 over 2 pi. So it will be 4 over 3. So this will be plus 4. Okay? So simply a1 is equal to what? A1 is equal to, that is negative. Okay, so it is 20. So this one, if we find the middle term, or we find the LCM to 3, so 12 is to 16 over 3, times this one to be 20 over pi. Isn't it? Because here it is 3. So then it's 4 plus 12. So 16 over 3 divided by 2 is 8. So So wait, I have minus n. Wow, so this is minus. This is minus. So if this is minus, here we have minus 4. Wow. So 4 minus 12, which is negative 8. So negative 8 times 5, negative 40 over 2, negative 20. And this is negative 20 over 3 pi. Okay? Negative 20 over 3 pi. So again, you have to find for what? When n is equal to 2, that's your homework. Okay? When n is equal to 2, the answer is equal to negative 20 over 3 times 5 pi. And again, when n is equal to 3, you have to find a3 is negative 20. Negative 20, 5 times 7 pi. Negative 20, 5 times 7 pi. Okay? Okay, so those are the Fourier coefficients. So, ladies and gentlemen, to end this fantastic and beautiful session, so you go for the 15 steps. Okay, the 15 steps. So the 15 steps, you say that recall the general Fourier series. So to recall the general Fourier series is f of x is equal to a naught plus sigma notation from n is equal to 1 to infinity an cos of nx plus bn sine of nx. So right now our Fourier coefficient is no longer depends on x, but depends on theta. This is equal to a naught plus what? Summation from n is equal to 1 to infinity. And then there we have what? We have an, then cosine of n theta plus what? 0, because bn is 0. So now, if that's the case, we have f theta is equal to a naught plus what? Plus a1, then cosine of what? Of theta, then plus what? a2, cosine of 2 theta, then plus what? a3, cosine of 3 theta, plus a plus dash dash dash. So the Fourier coefficient I, which is the name of our function, is equal to a naught. What's a naught? Our a naught is 10 over pi. 10 over pi. So 10 over pi plus a1. a1 is what? It's negative 20 over pi. Over pi or over 3 pi? Let me check. Over 3 pi. Then you have what? Cosine of theta. Then minus what? Negative 20 over 3 times 5, which is 15. Then cosine of 2 theta. Then minus 20 over 3 times 7 times 5. So we have 3. It's 5. 5 times 7 pi. Then you have what? Cos of 3 theta minus dash dash. So, therefore, ladies and gentlemen, our Fourier series of the given function so therefore, we say that the Fourier series of full wave is I is equal to so 10 pi is common, is equal to 10 over pi. Then we have what? So there we have 1 minus what? Twice over 3. Then we have what? Cos of theta minus what? Twice over 15. Then this is cos of 2 theta. Then minus what? Minus twice over 35. Then cosine of 3 theta minus dash dash dash. So this is the final response. You have to check your solution. If you got this solution, then I would like to clap my hands for you, and even also other online students clap their hands to congratulate those higher engineering students and higher scientific students who have got this question. So the homework is just to find what. So find what. So this is the homework. So this is homework 7, and also the homework is prove that if A3 is equal to that expression. So this is the end of lecture 6 of problem solving of Fourier series of periodic function of 2 pi. Wonderful. You know, actually that it's kind of, to me, I would like just to continue on teaching you and teaching you and teaching you and teaching you. But let me end there because I can overdose you. What I've given you, just watch this video several times as well as you can. But I would like just to remind you, whenever you join any school, any college, or any institutions, or any university, the first thing that you have to do is registration. How are you going to be registered in these online schools? Just watch on your right hand side, you'll see a button which has been written subscribe. Subscribe. Okay, subscribe. So click these buttons. First of all, you should have an email, a Yahoo, or should have a Yahoo or a Gmail, and sign in YouTube. And then you see this button, click it. When they are against, after you click it, the text will change from subscribe into subscribed, and then the bell will appear. Why should you subscribe? That's a nice question. Why are you subscribing? You know, the aim of you to be registered is in the physical colleges or institutions or universities. One of the objectives is, in case there are any change or any information regarding to your course, or regarding to what or to where you are studying, or regarding about maybe that the sessions is not there, or there's a new lecture, or there's not, then they have an access to give you the information. So similarly, the YouTube community will give you notifications once I add a new video. I have a plan, have a vision, and it's the picture, big picture in my mind, to prepare more than 500 videos or 40 of higher engineering mathematics and higher scientific mathematics, on which that will be focusing on the syllabus of TCU and the NATE in Tanzania, right? That will have all the students who will be pursuing higher engineering mathematics and higher scientific mathematics in undergraduate level in Tanzania, in Africa, in Serbia, in Nigeria, in South Africa, in Zimbabwe, in United States of America, in UK, in Singapore, Indonesia, in India, in Australia, in Pacific countries, in Caribbean countries, and even including that in Bahamas and different places around the world. So this is what I've prepared for you. I thank God, first of all, who have created me in His own image and likeness. When you see me, I have the image. God has created me in His own image and likeness. So I thank God for that. And I thank God also who have been with me during the preparations of this fantastic session. And I thank God who have been with you, who have given you an opportunity to join me and enjoy the beauty of higher engineering mathematics, and enjoy the beauty of Fourier series, and enjoy the beauty of limits or theory of the limit of the function, and enjoy the beauty of Laplace transform, and enjoy the beauty of partial derivatives. So I thank God, and I thank you also for tuning in. I invite you in the next session or in the next lecture, which will be lecture 7, where we are going to start a new topic. I'm going to teach you about Fourier series for the non-periodic function. Don't miss it, please. Invite your friends, invite your classmates, invite your college mate, invite also your institutions mate, invite also your departments mates who are doing higher engineering, and invite them to come and enjoy the beauty of higher engineering mathematics and the beauty of higher scientific mathematics. So again, in case you feel from your heart that you want to offer God the freewilling Thanksgiving offering for this program that coming to you without any payment. You are not doing any payments. We are providing these contents free of charge. Why? Because God told me to do that. It's not a simple decision, but it took me more than 6 months to agree. But God has given you an invitation in case you want to offer Him your freewilling Thanksgiving in order to support the running cost for this program, so that more than 500 videos recorded by the curriculums of Tanzania under NACTE and under TCU will be in air for the present and future generations. Don't hesitate yourself to send your freewilling Thanksgiving. That will support the running cost that you use every day in productions of videos and recordings and everything in online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. So send your freewilling Thanksgiving to this telephone number 0759 745331 of any amount according to what you have planned, according to what your heart and according to what God has told you to offer from your heart, and that's also you have to offer it generously. Right? Thank you very much for tuning me. Thank you for having me. I'm waiting your questions in the comment section. I'm waiting your comments in the comment section, whether you understand this session. I'm waiting your discussions with other students worldwide in the comment sections of this video. So until we meet in the lecture 7, may God bless you and protect you throughout your learning of higher engineering and scientific mathematics for the rest of your life. Until I find you and until I meet you in the next sessions, may God keep you. This is Sir and the engineer Olenjolai Moko from Tanzania. Thank you. May God bless you.